In this video, we're going to evaluate the integral of 1 over the square root of 9 plus x squared. If we've done a couple of others where it was a 9 minus x squared in the radicand, and another one where it was x squared minus 9 in the radicand. So just trying to illustrate the different trig substitutions that you can use. And I put a link to those others in the description in case you want to refer to those. In this case, we have a radical again, but in this case, it's the sum of two squares, 9 and x squared. So we've done the one involving secant, the one involving sine, and I mentioned that the version involving, or the method involving sine, you can also use cosine. The answer would have a different look to it, but it is another answer to the integral. The main ones, though, involve tangent, secant, and sine. So for this one here, here's my setup. I let x equal to 3 tangent theta, which tells me that tangent of theta is x over 3, or the opposite side over the adjacent side of the right triangle. The derivative here, dx, is derivative tangent here is secant squared. Of course, you have your constant. So the dx is 3 secant squared theta d theta. And then we have the radical 9, the square root of 9 plus x squared. If I replace the x here and put a tangent theta there, then under the radical, I'm going to get 9 plus. That'll be 3 tangent squared, so this will be 9 tangent squared theta. And if I factor out the 9, I'll get 1 plus tangent squared theta. But this 1 plus tangent squared theta, that's your identity involving secant squared. Secant squared theta is equal to 1 plus tangent squared theta. So in place of this, I can put secant theta. But remember, that's under the radical. So it's secant squared theta here is equal to 1 plus tangent squared theta. Take the square root of secant squared, and I get secant theta. So in the integral, we'll have a dx. I'm going to replace it by 3 secant squared theta d theta. We'll have the radical and the integrand. I'll replace it by 3 secant theta. We'll put an equals here. Now we have the integral. The dx again is replaced by 3 secant squared theta d theta. And this radical, replacing the x by 3 tangent theta and simplifying, will give us a 3 secant theta. And then just simplify here. The 3 and the 3 here divide out. Secant squared theta and secant theta will simplify to secant theta d theta. So after making the substitutions and simplifying, we get the integral of secant theta d theta. And this is one you should know. I think I mentioned this in the last video. You should know the integral to this. This is one that I actually did in another video using a u substitution. And I'm just going to give you the answer to this. Like I said, just like you should know the integral of sine, cosine, tangent, derivatives of those and so forth. You should know this one here. And this is the natural log of the absolute value of secant theta plus tangent theta. So again, the integral of secant theta d theta is the natural log of the absolute value of secant theta plus tangent theta plus the constant of integration. The only thing next, though, of course, is to put this in terms of the original variable. The original variable was the variable x. So to do that, you simply go to the triangle. One way to do it there. Some cases you might not need the triangle, but this tells me that the natural log then, and then for secant, look at the triangle. Secant is the hypotenuse, square root of x squared plus 9 over the adjacent. So this is just going to give us square root x squared plus 9 over 3. And then the tangent theta, again from the triangle, opposite side over the adjacent side, so this will be x over 3. This is plus the constant of integration. So again, the final answer, if you leave it in this form right here, is the natural log of the absolute value of the square root of x squared plus 9 over 3 plus x over 3 plus the constant of integration. The only thing we could do here, and I've mentioned this before, sometimes you'll work out a problem and somebody gave you the answer, or you got the answer from the back of the book and it didn't match. This is correct here. And if you gave me this answer on a homework or a test problem, I would say great. Unless I give you special instructions to simplify to a certain point. But other than that, this is a good answer. But let me take another step here. And this is what we would do. I put these into one. You have the denominator of 3 here. Both of them have denominator of 3. So let's just do this. Bring this over like this. I could write it this way. And then what I'm going to do here is I'm going to call this constant of integration a C1. This one still will be C1 because I haven't changed it. And then I'm going to say, there's a plus here. Anytime you have the log of a fraction, you can express it this way. So it would be ln of the numerator, natural log of the numerator. So this would be the square root of x squared plus 9 plus x. And it's plus, so it's a log of the numerator, which I have right there, minus the log of the denominator. The denominator here, remember, it was a 3 here. So it'd be like this. And we still have the constant of integration, which I called C1. But then natural log of 3, notice this doesn't have a variable. So this is a constant. That's a constant. So some instructions will expect you to write this constant with the regular constant of integration here. So we put those two together. And we say C1 then is a constant, minus ln of 3 is a constant. Let's put them together. So I take these off, and I just say plus. So the minus ln of 3 is put together with the regular constant. And you'll see this as your answer in most textbooks that will have a problem like this. So we can say this is then the final answer. Like I said, this one's acceptable to me here, but you might see it this way. Natural log of the absolute value of the square root of x squared plus 9 plus x plus the constant of integration. Thanks for watching. We'll see you next time.